I'm back again. I'm here to talk about energy. Are you getting it? Good. Now, please do not forget to like, share, and subscribe on our YouTube channel. Thank you. Now, let me talk about energy. Energy. I hope you enjoyed the previous one, work. Good. Now, what is energy? Energy is the ability to do work or the capacity to do work. Are you getting it now? Work and energy, they are similar. Are you getting it? You need energy to do work. Can you see that? Now, the unit of energy is also joules. The unit of work is also joules. Are you with me? Good. Now, we have known it previously that we have different forms of energy. Are you getting it? Different forms of energy. Now, we have mechanical energy. Mechanical energy. We also have electrical energy, and so on. Of course, we have more than two. But what we are interested here more is on mechanical energy. Are you getting it? Good. Now, we also said this energy can be transformed. That is, can be converted from one form to another. According to the law, principle of conservation of energy. Energy can neither be created nor destroyed, but can be converted from one form to another in an isolated system. Yeah, what I mean by isolated system is any system that no any external force is acting on it. That is me, which means mechanical energy can be transformed, which we have done in our previous classes. Now, mechanical energy is made up of two types. Mechanical energy is made up of two types. Mechanical energy is made up of potential energy and kinetic energy. Potential energy and kinetic energy. Now, what is potential energy? Potential energy is the energy possessed by virtue of its position. When we talk about potential energy, look at me as I demonstrate potential energy. A body swinging, oscillating from one position to another is potential energy. Are you getting it? From one position to another is potential energy. Body possessed by virtue of its position. And potential energy can be given as mgh. Now, potential energy is also known as stored energy at rest. Are you with me? Any body or any object that is at rest, that means that body is not moving, there is potential energy. Are you with me? Now, look at this duster. This duster is not moving, it's at rest, which means that body is at rest, it has potential energy. Even we as human, there is a potential energy in us. It is the potential energy that is enabling us to talk. Are you getting it? There is a chemical potential energy. So potential energy can also be defined as energy at rest. Are you getting it? Or energy by virtue of its position. Thank you very much. Now, we have examples of potential energy. For example, a magnetic force at rest is a potential energy. Electrical forces at rest is a potential energy. A stone resting on a table is a potential energy. A mango fruit, unplucked mango fruit resting on the tree is a potential energy. Any energy that is at rest or any object that is at rest possesses potential energy. Also, a spiral spring at rest, pendulum bulb is a potential energy. Are you with me? So, and we are given a unit formula for potential energy as mass times acceleration due to gravity and its height times the height. Are you getting it? Good. That is what's called potential energy. Now, let's go to kinetic energy. Now, what is kinetic energy? Kinetic energy is energy possessed by virtue of its motion. It means that any object or body that is moving possesses kinetic energy. Listen, any object or body that is moving, is on motion, possesses kinetic energy. For example, a car moving or an athlete running a race it possesses kinetic energy. Are you with me? Or a mango fruit falling from up to down possesses kinetic energy. Electric forces in motion, magnetic forces in motion means that any object in motion possesses kinetic energy. You understand? Good. Now, formula for kinetic energy is given as half mv squared, where v is the velocity, while m is the mass. V is the change in velocity and m is the mass. Formula for kinetic energy. Are you getting it? Good. Now, there is something I also want to say. Like I said, mechanical energy can be converted, can be transformed. Mechanical energy is conserved. Are you getting it? Now, which means that from the principle of conservation of energy, in an isolated or closed system, the total amount of energy is constant. It means that energy cannot be created nor destroyed, but can be converted from one form to another. Which means it means that potential energy, the sum of the potential energy plus the kinetic energy will be equals to 0. Which means mechanical energy is conserved. This is a conservative field. In mathematics, we call it a conservative field. Potential energy plus kinetic energy equals to 0. It means mechanical energy is conserved. It means that potential energy, which is mgh, plus kinetic energy half mv squared equals to 0. That's what it means. From here, we can get the total amount of velocity, the maximum velocity here. The maximum velocity. Don't forget, v stands for the velocity. Means that mgh here equals to half mv squared. It means the sum of the potential energy must be equal to the sum of the kinetic energy. It means as well it is conserved. Mechanical energy is conserved. In this equation, mathematical equation, we can make V the subject of formula. We can make V the subject of formula to get the total amount of energy. The total amount of energy. The total amount of energy. Alright. Now from here, let us make V the subject of the formula. Are you getting it? This is mgh equals to half mv squared. In making V the subject of formula, we divide both sides by this. Here, mgh. Sorry. We multiply both sides by the denominator, which is 2, in the right hand side. We multiply both sides by which is LCM. 2 times this, we have 2 mgh. Equals to this 2 go to 1. 1 times 1, which is mv squared. Are you getting it? Now let's divide both sides. We are making V the subject of formula. Use your change your subject formula theorem. We make V divide both sides by the coefficient of V squared, which means 2 mgh all over m equals to mv squared all over m. You see that? Now there is something similar here. M and m, they are common, so this will cancel out this. So here we have V squared equals to 2 m will cancel m here also, 2gh. Yeah. But we don't leave it like this in mathematics. You take the square root of both sides. Are you with me? You take the square root of both sides. When we take the square root of both sides, we have V equals to square root of 2gh. Now this is the maximum velocity. The maximum velocity. The maximum velocity. Now note that we can also use this one in escape velocity for an object. The maximum amount of energy required for a satellite or astronomical body to escape from the Earth's gravitational field. We can also use this formula. Now, this is the maximum energy. Now, let me also explain this practically using a spiral spring. Are you getting the oscillation? Now, we can do this. Look at the diagram here. Now, you tie a spring or a rope. A rope. Now, tie the pendulum bulb, a mass here. I can see. Or also demonstrate potential energy and kinetic energy here. Are you looking at the board? Good. Now look at this place now. I said we have two energy being converted here, forms of mechanical energy. Are you with me? Now I said potential energy possessed by virtue of its position. And the body is oscillating to and fro. You see that here we have potential energy position, potential energy, maximum potential energy. Also we have maximum potential energy here, as you can see on the board. Now in the center we have kinetic energy. Kinetic energy. Kinetic energy. You see, this explains the conservation of mechanical energy, which means that potential energy is converted to kinetic energy. From kinetic energy back to potential energy, from potential back to kinetic energy, which means energy is being restored. Energy is restored, yeah. Are you getting it? Here is potential, and we have maximum potential energy, mgh. Maximum potential energy, h here is maximum. We have maximum kinetic energy, half mv squared. Maximum kinetic energy, V here is maximum. We also have maximum potential energy. Here, H here is maximum. Are you getting it? Potential energy, and kinetic energy. Potential energy convert as it's oscillating, converted to kinetic, from kinetic back to potential energy. Are you with me? Good, thank you. Now let us take calculations. As you know, in physics, there is always theory and calculation. Are you with me? Good. Let me clean here. All right. Now we have a question on the board here given to us. A body of mass 4 kg is acted upon by a constant force of 12 Newton for 2 seconds. Calculate the kinetic energy gained by the body. Calculate the kinetic energy gained by the body. Now, like I said, when you see a question like this, always endeavor to write out the parameters. A body of mass, where you have mass here, as 4 kg, 4 kilogram, as the unit of mass is kilogram, acted upon by a constant force of 12 Newton. Force here, force, 12 Newton. For 2 seconds, time for 2 seconds. For 2 seconds. Full stop. We are asked to calculate the kinetic energy. Note that the formula for kinetic energy equals to half mv squared. When you look at the board, look at the formula here. We don't have velocity. We have mass. Now, we have to look for a way to get the velocity. Are you getting it? Now, we said force can be defined as the product of mass and its horizontal acceleration here. Force here. Force. F equals to mass times acceleration here. Are you with me? That is F force equals to ma. Now, we can make acceleration the subject of formula by dividing both sides by the coefficient of A, acceleration, which means that when we divide both sides, we have A equals to force over the mass here, which is equals to the force here. We have force as 12 Newton, and the mass as 4 kg, 4. Now, you can see, now 12 divided by 4, everything here will give you 3 meters per second square. Now, we have gotten the acceleration. This is the first step. We are gotten that. Now, we still need to apply equation of motion to get V, since we have gotten acceleration here. Therefore, acceleration, A equals to 3 meters per second square. Are you with me? 3 meters per second square. Now, let us calculate the velocity before we can substitute here. Now, using the first equation of motion, we said V, final velocity equals to initial velocity plus acceleration times time. This is the first equation of motion. Are you with me? The first equation of motion. Now, here, the velocity here is given as 0. Final velocity is 0. Initial velocity here is 0 plus acceleration. We have gotten acceleration as 3 times the time, which is 4 seconds, which is 2 seconds here. So therefore, V will be equals to 0 plus 6. 2 times 3 is 6. We have V as 6 meters per second here. Because its initial velocity is 0. A body of mass, 4 kg, is acted upon by a constant force. So we take the initial velocity here as 0. Are you getting it? So we now have the velocity, 6 meters per second. 6 meters per second. Let me clean here. 6 meters per second. Therefore, we have here force here. We have acceleration as 3 meters per second square. Don't forget, if you have calculated, we have the velocity here as 6 meters per second. We also have the mass here. Mass as 4 kg, 4 kilogram. And the force here, we have as 12 Newton. 12 Newton. Are you with me? 12 Newton. Now, we said kinetic energy here equals to half mv squared. Here, we can now substitute the values here, which is equals to half times the mass. We have the mass as 4, don't forget, times the velocity. We are gotten as 6 squared. 6 squared, which is equals to, let us solve our mathematics here. 6 squared is 36 times 6, which is 36, which is half times 4 times 36. Let's do it gradually. Now, 2 going 4 will give you 2. Therefore, everything here will now be 2 times 36. So, what is 2 times 36? When you multiply 2 times 36 to give you 72. Everything here will give you 72 joules. Don't forget, the unit of work is joules. So, the kinetic energy here is 72 joules. 72 joules. Now you have seen it. All of viewers, I hope I've explained. Please don't forget to like, share, and subscribe on our YouTube channel. Thank you.